110. All right, we are going to start by actually looking at the graphs of these, and there's a reason for this. So it says we're going to look at the inverses. We did reciprocals, all right? So secant, cosecant, and cotangent, those are reciprocals. These are inverses. They're two completely different things, okay? So a function has an inverse if and only if it's a one-to-one function, okay? That means it passes the horizontal and vertical line test. However, if the domain is restricted to a certain interval, the sine, cosine, and tangent functions have inverse functions, all right? So here's the thing. If the domain is restricted to a certain interval, so we're going to have to restrict things, because look at these sine and cosine graphs on the wall. The inverse would reflect in the, when we have an inverse graph, what does it reflect in what line? The inverse? Y equals x. Remember the inverse functional, because algebraically, how do you create an inverse? What do you exchange? The x and the y. You change x and y, right? So it reflects it over the line y equals x. So if I did that with those, basically it would make them stand up straight, right? And if it did, then it would make them look like this. And would that be a function then? No. So that's why we have to restrict the domain, okay? So we're going to look at that. Because remember your parabola, if you have a parabola, looks like this, and then you do the inverse, it looks like that, right? Okay, so that's kind of what's happening here. But so we have to restrict the domain. We had to do that for parabolas too. We didn't get to use this part because that's where the square root function comes from, and that's because that wouldn't make it a function. So we're going to graph these and figure out where our restrictions are. And it says when graphed on a restricted interval, the inverse of the sine function is the arcsine function, which is written as arcsine, which is the same as sine inverse. So sine inverse, inverse sine, arcsine, they are all exactly the same thing. When you first learn this stuff in geometry, when you're doing the right triangle trig stuff, we call it sine inverse or inverse sine. Arcsine is just, like I said, another way to say it. It's kind of the big boy and girl way to say it, but we really are going to use both. So you just need to know that they're the same. We're not trying to do something different here. So the inverse of the cosine function is arc cosine, which would look like this, which is also cosine inverse. And then the inverse of the tangent is arc tangent, looks like this. Okay. Everybody okay with all that so far? Maybe, hopefully, kind of. All right, so let's look at arcsine. So when we have, I want you to draw these little pictures over here. When we've been graphing sine, I've told you take this parent function and sketch that little piece right there so you have something to graph with, right? So we are going to we're going to sketch kind of what we did with the fettuccine. So just draw that. It doesn't have to be perfect, but just to get an idea of what's going on here, okay? So I need to restrict the domain here. And when I do that, it's going to have to be a one-to-one function. Right now, this passes the vertical line test. It does not pass the horizontal line test, and that's the problem, right? Because it's not going to pass that horizontal line test. So if I start here, right? I'm going to start here, and I'm going up this function. When I get to here, I'm good so far. Is that piece still a one-to-one piece? Yes. But if I start coming back down, is it going to be? No. But guess what? I'd also be repeating my y values, right? So I've at least taken care of all those positive y values. Well, if I start going this direction, then I'm good until I get right here. And then not only would I start repeating my y values, but then it wouldn't be one-to-one anymore. But that little section right there, is that section right there a piece that's one-to-one? Yes. Okay. So what is this x value right here? Pi halves. Good. And this right here is negative pi halves. Good. Okay. Now I want you to think about this. This is a graph on a rectangular coordinates like our fettuccine. Our unit circle is a completely different type of graph, right? We're talking different quadrants, everything. So thinking unit circle-wise, not about these, because I still have quadrants 1, 2, 3, and 4, but completely different thought process with my unit circle. So if this is talking about my unit circle, I know that all students take calculus. So sine is positive here. It's negative in the third and fourth. However, This little section here, this piece right here represents my first quadrant angles from 0 to pi halves. And then this little section right here represents my fourth quadrant angles from 0 to negative pi halves. And all the sine values are negative down there. Okay, we good with that? Because there are 4 quadrants, right? In 2 of them, sine is positive, and in 2 of them, sine is negative. So the sine values repeat themselves, right? So since it's not just, the inverses just aren't as repetitive. For the regular sine function, it goes on to infinity, right? Forever and ever, and I can repeat, and I have all these angles I can do. But for arc sine, it's very restricted. I only get to go from negative pi halves to pi halves. Okay, everybody okay with that so far? To make it 1 to 1. So if I graph this part right here, that means I'm here at negative pi halves, I'm at negative 1. I'm at 0, and at pi halves, I'm at 1. So I'm basically going to draw in my sine function, but only from there to there. There's no arrows here. That's why the arrows were so important on the other ones, because here we are literally stopping. You don't get to go any farther at all. And it looks like this. Okay? It's just this part right here. So the domain of what I just graphed, what's that domain? Good. Negative pi halves to pi halves. Do I include them? Yes. What is the range? Negative 1 to 1. Okay. Everybody good with that? Any questions at this point? Okay, so now we are going to graph arc sine. So we are literally going to exchange x and y. So this point right here, which was at pi halves 1, is now going to be at 1 pi halves. 0, 0 is at 0, 0. The negative pi halves, negative 1 would be at negative 1, negative pi halves. So I just graphed the same 3 points, but it's not going to look exactly the same because at let's see, like pi 6, right? Pi 6 is somewhere right around in here. What is the sine of pi 6? 1/2, right? So pi 6, I'm up here at 1/2. So at 1/2, I would be at pi 6, which would be like down here. So basically what happens, we don't have to plot all those points, but it inverts your concavity, okay? And so this is talking, we haven't really used those words that much, but that's one thing that's big in calculus. You're going to look at, are things concave up, concave down, like that tells you a whole bunch about your function. So this is concave down right here, right now. Right here, it's concave up. So it just kind of flips, okay? Easy enough? So what's my domain here? Negative 1 to 1. And what's my range? Negative pi halves to pi halves. Because just like any other inverse you do, when x and y change places, the domain and range change places. Okay? We okay with that? Any questions at this point? Okay. Let's look at cosine. So we're going to draw a little graph right here. So what we've been doing for cosine when we're graphing that is to draw this part of the parent function. So we're also going to draw it over here, like so, just like we did on the other one. And then let's look at what happens with this one. So if I start with 0, because we like to start with 0, and I start drawing it here, I'm 1 to 1 until I get to here. Does that make sense? If I start back at 0, can I go to the left at all and keep it 1 to 1? No, I can't. So that's all I get to actually draw, right? What is this x value right here? Pi. This is at pi. So this part right here was that pi halves. So let's think about unit circle. This right here, from here to pi halves, that's my first quadrant angles, right? And see how all the cosine values are positive? Then when I get from pi halves to pi, which is the second quadrant, do you see how all of your cosine values are negative? It's because cosine's negative in the second quadrant of the unit circle. So this is negative. I don't get to use the fourth quadrant for cosine because it's still positive and it wouldn't be 1 to 1. So sine is restricted to quadrants 1 and 4 to get a positive and negative. Cosine is restricted to quadrants 1 and 2 because cosine's positive here, negative here. Ask me a question if you got a question. What are you confused about? Okay, but it's not. Remember, these quadrants are, I'm talking unit circle here. Unit circle values. 0, pi halves, pi, oh, no, just pi, 3 pi halves. Unit circle, different quadrants than this. Okay? So in, yes, no, yes. We're talking different values. Okay, on the unit circle, there's a point here. Yeah, this point is 1, 0, right? All students take calculus. This is the unit circle quadrants I'm talking about, 1 and 2. Does that make sense? Not these quadrants. Do I have quadrants 1, 2, 3, and 4 here too? Yes, but these, I'm talking different pieces of information, okay? Okay, good. So that's different worlds. Are we good? Once that clicks, it'll be better. Okay. So let's graph just this part. So I'm going to graph 0, 1. I'm going to graph pi halves 0 and pi negative 1. And it looks like this if I'm graphing it in the xy coordinates that we're used to as a function. My unit circle values, though, that's what these y values are. Remember, the angle is my input. The output is the actual cosine values that I get. Okay? All right, so the domain here goes from 0 to pi. And my range still goes from -1 to 1. So now when I exchange these, 0, 1 becomes 1, 0. This pi halves 0 becomes 0 pi halves. The pi -1 becomes -1 pi. And then this is my graph. So my domain goes from -1 to 1, and my range goes from 0 to pi. Okay, so let me maybe kind of clear that up a little bit more, because I know it takes a while for that whole idea of, we're talking about different types of quadrants, to click. In my sine inverse here, okay, do you see how my values, or do you see how my angles, because the pi stuff represents the angles. Now my y values the angles. My angles can be positive or my angles can be negative. That's what's happening here. Positive angles in quadrant 1, negative angles in quadrant 2, right? So for cosine, do you see how all of the angle answers are positive? Okay? That's because even when I have negative ratios, like -square root of 2 over 2 or whatever, I'm still talking positive angles because I'm using quadrants 1 and 2. I'm going from 0 to pi instead of from -2 pi, negative pi halves to pi halves. Okay? I'm restricted to just those values. Okay, we good with that so far? Okay, it'll get better. Just kind of stay with me. Ask me a question if you got it, but I know it takes a little while for it to kind of click. All right, so let's look at tangent real quick. So the tangent that I had you draw for the parent function looked like this, right? So we're just going to finish this part off and add that. At least that much, and then it would repeat and repeat, but we're not going to do all that stuff. Okay, so for tangent, if I start here at 0, and I go all the way up to infinity up here, all that piece is 1 to 1. We agree with that? Yeah. And then if I start at 0 and go this way, all the way down, so this whole little cubic looking thing that's not cubic is all 1 to 1, right? Then I have an asymptote. If I start over on either side of the asymptote, would I still be 1 to 1? No. So this is what I'm restricted to for tangent. Just that part right there. Okay? Because remember this. These are my angle values right now. My x-axis, when I'm graphing sine, cosine, and tangent, not the inverses, the x-axis represents the angles. So I have positive angles from 0 to, what's this value? Pi halves, right? And this is negative pi halves. Okay, so my angles again go from negative pi halves to pi halves because tangent's positive here and negative here. So when I graph this tangent, I have asymptotes at pi halves, 0, 0, and then I'd go to pi fourths 1 and negative pi fourths negative 1 to get this drawn in here. My domain goes from negative pi halves to pi halves. Do I include the pi halves this time? No. So these are parentheses because those are asymptotes, right? What's the range? Good. Negative infinity to infinity. So now let's graph the arctangent. 0, 0 is still 0, 0. The point that is at pi fourths 1 becomes 1 pi fourths. And negative pi fourths negative 1 becomes negative 1 negative pi fourths. And those vertical asymptotes become horizontal asymptotes at pi halves. So it looks like this. Just like if you had think about the inverse cubic function. It's the same kind of idea, except there were no asymptotes there. So now my domain is negative infinity to infinity, and my range is negative pi halves to pi halves, and I do not include them. Okay. Everybody okay with that? Questions? Let me show you how we're really going to use this, because we're not going to graph this too terribly much. The graphs are there. We're doing that so you can understand how restricted it gets. We go from being able to go on to infinity to having a very, very narrow realm of possibilities here. So this says, use the unit circle to help you evaluate inverse trigonometric functions. However, remember that the domain and range are restricted on trigonometric functions. Okay? So we have sine and tangent are restricted to quadrants 1 and 4. So sine and tangent are restricted to quadrants 1 and 4. Cosine is restricted to quadrants 1 and 2 in the unit circle. You're picturing your unit circle with this, okay? Now, I'm going to write something down. I want you to think about this. Tell me, what is the sine of 7 pi sixths? Just the sine. Is it 1/2? Yes or no? Negative 1/2. Do we agree with that? This is equal to negative 1/2. Now, the sine inverse of negative 1/2 is not 7 pi sixths. Think about that. Just pause for a second. Let that soak in. There are an infinite amount of angles that would give me a sine value of negative 1/2, because I could keep going around the circle, right? But when I take the inverse is restricted. The only outputs I get for sine inverse, the only allowed y values or the outputs go from negative pi halves to pi halves. That's it. So I'm not saying this doesn't have a value, but the value is definitely not 7 pi sixths, because that doesn't live within negative pi halves to pi halves. You with me on that? So if I have a negative ratio, I know for sine then, if I'm restricted to these two, it's going to be a fourth quadrant angle, right? And that fourth quadrant angle, I can't even call that 11 pi sixths, because it has to go from negative pi halves to pi halves. So the sine inverse of negative 1/2 is negative pi sixths. Just think about that for just a second. If I have a huge stack of note cards out there, I can run through that and I can keep giving you different angles, and your answer can be negative 1/2 every single time. But if I say, what is the sine inverse of negative 1/2, there's only one possibility, because my range is so restricted. Okay, does that help a little bit? Okay, so let's think about this. Arc sine of 1, which just means what angle measure is going to give me a sine value of 1? What is that? What angle gives me a sine value of 1? Pi halves, because your y value is 1 up here at pi halves. Very good. Now number 2, the sine inverse of the square root of 3 over 2. Now remember, you can use the hand for this, because here's how I make sine square root of 3 over 2, yes? And so the sine inverse is what angle gives me a sine value of the square root of 3 over 2. What angle is that? Pi thirds. There you go. Same thing, but going the opposite way, okay? Arc sine of negative 2. What's your domain for arc sine? Negative 1 to 1. Remember when you're doing SOHCAHTOA stuff and we're looking for the angle measures, like I give you the size, you got to tell me the angle, so you take the arc sine because the sine gives you the angle back, right? And so the ratio that you're taking the inverse of can't be any bigger than 1 or any smaller than negative 1 because of the hypotenuse, right? So this right here, you can't take the arc sine of negative 2. Calculator's going to say error, right? So this does not exist. There's not an answer for this. Yeah, not DNA, DNA. All right, so cosine of negative square root of 2 over 2. Remember how we were writing these down the first time? Square root of 2 over 2 for cosine is pi fourths, right? But this is negative. So it's not going to be negative pi fourths because cosine has to be a first or second quadrant angle. So since it's negative, it's the second quadrant pi fourths angle. What is that? 3 pi fourths. Ask me a question do you understand why it's 3 pi fourths? Okay. Do you understand why it's not pi fourths? Okay, it's not pi fourths because pi fourths would be positive, right? Cosine is negative in these two quadrants. But for the inverse, I'm restricted to the second quadrant, right? So my second quadrant pi fourths angle is 3 pi fourths. Does that make sense? You good? Okay. So cosine inverse of 3 does not exist because you cannot take the inverse, cosine or sine inverse of anything bigger than 1. But remember for tangent though, it's a negative infinity to infinity, so you got lots of options. So arc cosine of negative 1. What angle gives me a cosine value of negative 1? Pi, because cosine is your x, right? So negative 1 is over here, and I get to go from 0 to pi, so the answer is pi. We okay with all that so far? All right. Arc tangent, square root of 3 over 3. All right, so this is positive, and tangent is restricted to quadrants 1 and 2. I'm sorry, 1 and 4. I pointed the right one, said the wrong thing. So if the value is negative, it's a negative angle in the fourth quadrant. If it's positive, we're in the first quadrant. So I know it's first quadrant. What would this be? Pi 6. Arc tangent of negative 1. What angle gives me an arc tangent, or gives me a tangent value of negative 1? Pi fourths, and it's negative 1, so it is negative pi fourths. You will never give me a negative angle answer for arc cosine. Remember, those are always all positive. All right, tangent inverse of the square root of 3. Pi thirds. Very good. All right. Ask me questions. Questions. Does it just need to kind of soak in for a minute? So here's what I'm going to do, and here's what I want from you, because I don't always ask that much from you. I'm going to give you the assignment. We haven't even done these yet. We will. They're not that bad. But there are 8 problems at the top that go with this. Do these before tomorrow. You have like a few minutes left. You could get probably some of them done now so that we can talk about these tomorrow. Maybe it'll make a little bit more sense to you, and then we're going to push on a little farther, okay? Yeah, we'll finish the notes tomorrow too. But do 1 through 8 before tomorrow for me, please. That's for your own benefit. I mean, I can do them for you, but if I'm just always doing it for you, it doesn't do you any good. So even if they're wrong, I would rather you be wrong, and let's talk about how you can think about it differently, okay? So do them. Start now because you got time.